begin. Hello everyone, I hope you are all doing well. In today's lesson, we're going to establish a local area network using a hub. And so in order to do or finalize this experiment, we will have some prerequisite knowledges and fundamental knowledges about basic IP addressing and types of cabling that we're going to use in order to configure the local area network. So in order to establish the local area network, we're going to use 4 PC and 1 hub. And hub is the intermediary devices. We can choose, or we could choose switches or router. The progression of these devices is going to be step by step. Since we're on the first fundamental level, we're going to start with the hub. In the next class, we'll use switch, then we'll use eventually router and the routing configuration of them and static routing. We're going to use the different local area network. Okay, so we have to first of all understand the overall cable type of cables. Okay, there are many different types of cable. We're talking about 2 fundamental cables that we're using in this scenario: copper straight through cable, and another one is copper crossover cable. So in which scenario we use which one, we have to understand based on the in devices and the intermediate devices that we're using. For instances, if we use 2 hub or 2 PC, then we want to build a connection between them, the 2 pieces. The wire that or cable that we're going to use is the crossover cable. And if we try to establish a connection between a hub, this one was hub, and the PC, the cable connection that we're going to use is copper straight through cable. So the conclusion is, if the devices are same, then we have to use the copper crossover cable, and devices are different, then we have to use copper straight through cable. And another knowledge we have to know, another prerequisite knowledge we have to have in order to finalize this experiment or conduct this experiment is the class of the IP addresses. So in the IP version 4, there are 5 types of class of IP addresses. So in the class A of the IP addresses, the range is 1 to 126, and if the starting or leading bit it starts with 0, then it is obviously the IP version 4, and class of that IP version would be class A. So, and for the class A, the network version and the host versions are defined as follows. First one is the network and the rest of them are host version. And for the class B IP addresses, the range is 128 to 191. So you may say, where is the 127? And where is the 0? Okay, 0 is used for network address definition. For instance, if you use something like that, 10.0.0.0, this 0 will define the network portion. Okay, network portion. And if we use the 255, it will define the host portion. Okay, so the class B IP addresses range start from 128 to 129, and the subnet masks would be, the first two portion would be network and the rest of them would be host. Okay, so these two would be unique for every single local area network is, and these would be the different. And for the class C IP addresses, the range would be 192 to 223, and the first three portion would be network, 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 and the rest one would be the host. So it would be different for every single individual PCs. Okay, so let's try to conduct the experiment using the Cisco packet tracer. Since we are going to use 6 or 4, we actually mentioned 4 in devices, we have to select the PCs, one here, one here, one here, and one here. And the intermediate devices, we have to choose a hub. The hub we're going to choose is PT hub. We're placing it in the middle of all of these PCs. Yeah, we're going to establish a star topology. Okay, since we're going to connect a in-device or PC with a hub, since it is going to be a different type of devices, the which type of cable we're going to use? Copper straight through cable. And let's connect it, and the hub has 6 ports. We can choose any of it. Okay, so let's do the same thing for this PC too, and for this PC, and also for this PC too. Okay, now since this whole local area network is going to be under the class C IP addresses, we have to just define it in the following order. So we are just simply going to add some tag. Let's put the tag 192.168.10.1. Since it is a class C IP address thing, the first 3 portion would be the network portion, the just last byte would be the host portion. It would be unique and for every individual PCs. So let's begin 192.168.10.2 and so on. For the third PC, it would be 192. Okay, I did a mistake. 192.168.10.3. And for this PC, it would be like something 192. 192. Okay, let me just remodify it. Okay, 192.168.10.4. okay, and let's just simply delete it. Okay, now we have to manually, we have just simply put the tag. It does not have to do anything with this PC. For the convenience, we are just putting the tag. The main thing we have to do, put the IP addressing manually. First, we have to click on the PC, then go to the desktop, then do the IP configuration. So, and we have to put the same IP that we have put on the tag over here. Okay, 192.168.10.1. And what would be the subnet mask would be 255.255.255.0. And it has been automatically sent over here. And for the next one, it would be in the same way, but the last host address, it would be different. Fast tree network addressing always will be the same for the same class of the IP addresses, and subnet mask will be auto configured, and it would be same way. We have to just put it there, 192.168.10.3 and so on. And for the last one, it would be something like this, 192.168.10.4. okay, subnet mask would be automatically set, and we have configured a local area network. Now the next thing we have to do is to check that if the messages are being sent. And with respect to this PC, we'll check every single one messages are actually being sent or not. Let's try to simulate it. Okay, the message has been sent successfully. We have to do it for this PC too. It is also successful. And for this PC2, and it is also being successful. Okay, we can also simulate it using the real-time simulation. Let's try to do it too. For instance, we want to send packages from this PC to this one. Let's try to simulate it. Okay, let's establish it. It is going, since it's a hub is a dumb device, it doesn't specifically remember the MAC addresses, so it just simply send all of the pieces until it gets to the destination. And since it gets to the destination, it will send a acknowledgement packages, and the PC1 will be getting the acknowledgement. And by doing that, it knows that the message is being successfully sent. So if we think about the security measurement, if we try to send a confidential data to another PC, this medium is very inconvenient because every single PC is getting that password. So in that choice, in that scenario, we have to use Swiss. Okay, and another thing we can do, we can also see it using pinning this PC with this PC's IP address. We can also simulate that. In order to do that, we have to go to the PC and use the command prompt and use the, since we're using this PC, we have to choose any other PC, none but this. Okay, so let's try to establish a connection, this PC with this one. So the PC9's IP address is something like this, ping 192.168.10.3. Okay, let's see what happens. Replay is being sent. It is sending some data or packet to this species, and this species in response is sending back some data to this one. The total data is being sent is 4 and also received 4. So the efficiency, if we measure the efficiency, is 100%. Okay, that is also being sent. So that is for the first video. Hopefully you have enjoyed it, and thank you very much.